let's start here then. The bacterial fermentation of grain to produce ethanol forms a gas with percent composition 27.29% carbon and 72.71% oxygen. What is the empirical formula of the gas? Okay, so where are we going to start off at? What is the assumption that we're going to make?
That equals 100 grams.
We're going to assume that altogether it equals 100 grams. So then what am I going to do now?
You are gonna
Don't you transform the percentage into decimals, so you move them two places to the left?
I could do that, or I could just assume that I have 100 grams. Since everything's 100%, it's based upon 100. I could just assume that I have 100 grams. Then how much, if I have 100 grams, how much of it would be carbon?
So we're gonna, because it's empirical formula, we have to find out how many moles there is?
Yes, we need to find out how many moles there are.
Yeah.
So what am I going to start off with? That's what I'm asking.
So would the percents be represented as grams since the 100% is 100 grams?
Okay, so if we assume that we have 100 grams of this substance, then how much of it would be carbon?
27.
27.29 would be carbon. And then how much of it would be oxygen?
72.
And that makes sense, right? Because when you're talking about percentage, you're assuming that you're starting with 100%, right? And so we could kind of just make that assumption that we have grams, 100 grams of that material. Okay, so how do I change it to moles? Because I heard Alexa says, you know, you just change it to moles.
What you'll do is that you'll go on the periodic table and find out the weight of the carbon. You'll put
Okay, what is the weight of carbon?
It's 12. So you put 12 grams and then over 12 grams of carbon over 1 mole.
So I'm putting 12 grams on top? Is that what you're telling me?
No, not bad. 1 mole of on top over 12 grams.
1 mole of carbon over 12 grams.
Yeah.
Okay.
And that should be 2.27 moles of carbon.
So my trusty, handy cell phone calculator. How many sig figs will I have?
4.
4.
Okay. Okay, so now what do I do with this oxygen?
The same
What?
thing.
The same thing. So what is the mass of oxygen?
16.
So I put it at the bottom or the top?
The bottom.
Okay. So 16. How many sig figs?
4.
Okay, so then what do I do?
You divide by the smallest.
Okay, you got to say that one at a time so I can actually understand what you're saying.
Divide by the smallest.
Divide by the smallest. Okay, so who's smaller?
Oh, carbon.
You know that no yawning is allowed. Okay, so what is my chemical formula or my empirical formula?
CO.
CO2.
Piece of cake?
Yes.
Any questions?
Mm-mm.
No questions?
Mm-mm.
Good. Okay. Are you guys ready for the next one?
Yeah.
Okay, so when we're trying to figure out the molecular formula, right, you were going to need the molecular mass or the molar mass. So if they give you the molar mass and they say, hey, figure out the molecular formula. So then all you have to do is first calculate the empirical formula and then use that to calculate how much you need to multiply by. Okay, so I know it's kind of hazy and everything like that. It's probably best if I just give you an example, right? Come on. Oops, I got carried away. So I have a compound. Say a compound has an empirical formula of CH2O, and its empirical mass formula is 30 AMU. All it is calculating the molar mass of CH2O. It's going to be 30. They're giving it. And the molecular mass is 180. So then all I have to do is, in this case, is to do what?
Divide your molecular mass by your empirical formula mass.
If I remember correctly, that's going to equal 6, right?
Yeah.
So then we take this here, our empirical formula, and we multiply each of those by 6. So we'll do like this. So then our chemical formula is going to be C6H12 O6. Piece of cake?
Yeah.
Not too hard, right?
Not when you put it in that way.
Say that one more time.
Not when you show us like that, no.
Okay. Good. Okay, now let's see if we can give you something that's a little more challenging. You know, that's too easy. Oops. So let me go back. Actually, hold on, one more. Because I think we went too far. Did we do this one?
No.
No. So a compound is determined to contain 1.71 grams of carbon and 0.287 grams of hydrogen. Determine the empirical formula.
I think we did that one.
We did this one?
Yeah, I
Okay.
have it in my notes.
Just making sure, making sure. So I do have one for you. That's a little more challenging. If you don't mind. Yeah, we did do that one. There's one more. What about this one? Did we do this one? A compound to determine, a compound is determined to contain 5.31 grams of chlorine and 8.40 grams of oxygen. Determine the empirical formula.
That also.
We did this one also?
Yeah.
God, we're so good. I didn't realize how good we are. Okay, good, good. So then I have one for you. 1 second. Okay, you guys ready? Everybody has it? Come on. I need to hear something.
Yeah.
Okay. Do.
So what you would do first, so if it weighs 100,
We're not talking to me. You're supposed to talk this over with your group.
Oh wait, we have groups?
Yeah. You don't pay attention. I'm gonna smack you.
I went to go get food.
I'll see you guys in a few minutes. 14 minutes. Baltazar, go to your room. Jeez. Okay. Okay, so your team is responsible for getting the information to us, and you got to tell us what's going on.
Okay. Gosh, I did it all on paper. But I do it on text or writing? Okay.
Do it by writing. Come on, I want you guys to understand how good I am at writing.
Okay. So what we did, we grabbed all the, what are these? I don't want to too much. They're percentages. Those are the grams, correct? Of the,
Of all the elements that are in.
the equation, or like the ones that are
So,
given to us.
Let me make sure, because you know, I'm a new student here and I skipped half the classes. So I just want to make sure that I understand everything. So you're saying that you grabbed all the elements. So are you saying that those percentages are going to represent what to me? What do they mean to me?
It's the amount of it's the amount that we have of each element that's given to us, like the carbon, hydrogen, nitrogen, and oxygen.
Okay. Oops, sorry. I didn't mean to put that big.
So we listed our given to start our work. So
I'll put this up top. There we go.
just writing.
So what is the first assumption that you made?
That we are given the grams of each, or well, the amount of each element listed.
Okay.
And then
Let me see. Let me try to annotate.
it's gonna take forever, Professor.
I'll help you out.
Okay.
Got you, don't you?
That's all right. I got plenty of time.
Oh,
It isn't beer 30 yet, so I'm okay.
carbon 16. Okay, so we listed down everything that we are given
Okay.
for each element. And then after that, so for every single one of them, we multiplied it by 1 mole of carbon over the amount that it weighs on the periodic table. By its,
Okay.
yes. So we put 1 mole of carbon divided by 12 grams of carbon. And then we do the same thing all the way through, but with the correct molar mass, or 16.
Okay, Erica, what do we do next after we do this? So after we get these numbers.
So you want to well, yeah, like take out the grams,
Okay.
and then you want to multiply through. So,
Okay.
so for carbon, we got 4.123 moles of carbon,
Okay.
and then for hydrogen, we got 5. Oh, you can't even see the point there. 5 moles of hydrogen. And then we got okay. And after we got
So I have a quick question. So I'm assuming there's decimals here that I just can't see because they're too lightly dotted.
yeah, hang on. Sorry.
Okay. Just want to be sure. Because I'm
Okay.
like, that math does not add up right. And there's one over here, right? Also.
Okay. And after you multiply through, you want to get the lowest one and divide
Okay.
it.
Okay, Alexis, what do we do after that?
So after dividing by the smallest decimal of everything to every one of them, you should get the empirical formula.
Okay. So what happens if one of them gives me like a really weird number? Like it gives me, instead of after dividing, I get like 1.25 something.
You can round
so if you give like a 1.25 example on like one of them, then you're gonna have to multiply each one of them by 4.
Okay.
Because you want whole numbers on those. You don't want any decimals, because you never have a carbon that's gonna be like I don't know, 8.2 or something like that. It just doesn't exist.
Okay.
So the empirical formula should be C4 H5 N2, and we got 1 oxygen. So that will be the empirical formula. But we need the molecular mass, so we still have a few more steps to do. Or molecular formula, sorry.
So who else is in your group? Primitivo. So how do I calculate the molar mass? I mean the molecular formula. What is the molecular formula? How does that differ from the empirical formula?
Mhm.
It's
Is he ignoring me?
I don't know if his mic's on.
What was that?
I can't tell if his mic. I don't know what's going on.
Text him. So somebody's going to answer for him since he's ignoring me. Eduardo, Eddie, are you there?
Yeah. Yes.
Help me out. I don't understand. So how do I get from my empirical
Okay.
formula to my molecular formula?
Okay, so what I did was I don't know if it's right, but I grabbed the total grams of those and I divided it by the 194.19.
Okay. And what did you get? Well, write it on the board. Show me. Because you
Okay,
telling me don't mean nothing.
Yeah. Hold up. Okay, so
So either mute your phone or mute your computer.
okay, so with the pen. So for that one is for carbons you have 12 of carbons.
Okay. So you're saying carbon weighs 12?
Yeah.
Okay.
And then you have 4 of those. So you multiply 12 times 4.
Okay.
Yeah, 12. Let me see if I could write it. 12. Is that too big? Yes. Times 4.
Well, we can see
And
it.
then you can see it?
Yep, I can see it.
All right. So then, and then the hydrogen is 1 times 5. And then for the nitrogen, it's 14 times 2. And then there's only 1 oxygen, so it's 16. So then everything is gonna, wait, shit. So 12 times 4, it's gonna be 48.
Okay.
48, well, obviously 1 times 5 is 5. And then 14 times 2 is 28. And then plus 16. Which you're gonna get 97.
Okay.
Am I right? Yeah, huh? So 97, and then you're gonna divide it by the 194.19 grams. So let me see. And that's the last step we took, me and my group. I was about to tell them when the time ended.
Okay.
Yeah,
So
but
and what do you get?
I
What
got
is-
0.49. Well, if we round it, so it's only 2 significant digits. It's 0.50.
Okay, wait. I'm a little confused. So you're telling me that you said you had 194,
Yeah,
19, and you're dividing that by
by the total.
97.
Yeah.
Okay. And that equals what?
Oh shit! I did it backwards.
Okay.
Yeah, my bad. So
That's all right.
so that's gonna end up being 2.00.
Oh, so 2. Okay, so now what do I
Yeah.
do with that 2?
So with that 2, I'm pretty sure you're gonna multiply by all of them. by every single element. So it's gonna be, let me write it down. So it's gonna be 2 right there. And then it's gonna end up being C8, H10, and 4 and O2. Shit, my bad, I have a fat finger.
Okay.
And it's right there. Is that it? Or
That's
is
it.
there more to do?
Nope, that's
All
correct.
right.
Piece of cake?
Sort of. We had some trouble, my group and I.
Yeah. So what was the problem?
Yeah. So what we were doing, me and Christian were discussing that, I don't know, somehow we were gonna multiply the 194 with every element, and he was doing that while I was doing other things, but we were just still discussing it. So like at the end, I was explaining how I was doing it, but then the time ran out and I couldn't explain it to them.
And ladies in the group, did you guys let them just talk?
No, there was someone else talking. There was
I was talking to.
You were talking to? Good. I told you got to keep them in check. Okay. Piece of cake, right? So you guys are ready for this because there's going to be one of these on the exam. And it may not be as pretty as this one. Okay?
Yeah.
Okay. What are we doing on time? We're doing pretty good. So, do you guys want to talk about your lab problems? 5 and 6?
Yeah.
Yeah? Okay. You will have one problem like that on the exam as well, like one of the lab problems on 5, and you're going to have an Excel problem. So I know you guys already know how to use Excel, right? So you guys as students are allowed to download Microsoft Office Suite. Did you guys do that?
Yes.
Yeah.
Everybody has it downloaded?
Yes.
Okay, so if we put our data, can you guys see my screen? Okay,
Yeah.
so if we put our data into the table, like they have it on the first problem,
Favorite it.
part 1. Everybody has their data in their table?
Yes.
Okay, so what you're going to do is to make a graph, you're going to go here and you can use a line graph or you can use a scatter plot. I prefer the scatter plot. So to be sure your data is presented right, we're going to go ahead and select data. And we're going to edit our series. So the first series that we're going to be looking at is going to be the millimeters of tryptophan. Our x-axis is going to be this first column. our y-axis is going to be the tryptophan column. Then let me fix that. Oops. Okay, so then I'm going to do the same second thing to the second one. My X. My Y. Fix this one again. Okay, hold on. My X and my Y. Okay, then we'll get rid of this one. It gave me too many. Okay, so I'm just going to go ahead and hit OK, and then we'll finish fixing up everything. So if we go over here and we say to the add chart element, so I'm going to select on one of my series. So I'm going to click on the dots. I'm going to go down to where it says more trend lines. So when I go to more trend lines, it opens up another little menu on the side here. Can you guys see that? These are my trend line options. So I think my line is going to be linear. If I want the equation to be shown, it'll display the equation. And if I want to see how accurate my equation is, I'm going to use your R squared. So your R squared value basically lets you know how good your data fits your curve. If your R squared value is 1, your data is perfect. If your R squared value is 0.99, it's good. It's really, really, really good. If it's 0.91, not as great, but it still fits decently. But if you're getting in the 70s or the 30s, then there's something wrong. That probably means that your curve is not linear. It's probably something else. So then I'm going to do the same thing with this guy. Add elements, go to trend lines, go down to more trend line options. Hit linear, display equation, display my R. And then I'm going to do the same thing with the last one. Okay. So now I have my X and my Y, well, my X, my slope, and my y-intercept, right? Piece of cake. Kristen?
It, I don't know. It was a lot because I never really use Excel,
Okay,
but I'll figure it out.
okay,
We could always go back and rewatch these Zooms, right?
yes.
And we do
I'll
that.
actually I'll give you, since it's gonna be a little late, it'll probably be a little bit when I get it. I'll send you the actual link as soon as I get it.
Okay.
Usually I have to decode it and then load it back up and trim it. Try to bleep out all my cuss words. A lot of bleeping.
So when are you gonna have these labs be due?
So these labs technically would be due tomorrow, but I'm gonna give you guys till Monday.
Okay.
So you'll have everything due on Monday and Tuesday, so.
Monday and Tuesday, lab 5, 6.
And you have your exam on Tuesday, right?
Yes. So 5 and
Okay.
6 will do Monday, and what about the other ones that we did over there?
So those are gonna be, they're gonna be due over time. They're actually listed when they're due. If you actually click
Okay.
on them, it'll tell you the date that they're due. Now, the reason why they're gonna be due over time, because you still have stuff to learn, and we're working on that. Okay?
I have a question about lab 5 and 6. I'm sorry. Do like a lab for them, or is just post the lab like with all them?
Can you repeat it one more time, please?
Do we need to do like a lab report on them, or just put
Yeah.
them on Canvas? I mean, on
Class
the
note. Yeah, so you need to do a lab report, but it's gonna be a minimal lab report. It's not gonna have to be, you don't have to put a hypothesis, right? The data is just basically your calculations, right? That's gonna be your data and your results, but you just wanna box it and make it neat so I can understand it. Okay? For like 5, okay? 6 is gonna be very similar, only thing you just have to put up the graphs and then also put up the data. That's it. Okay? So you don't have to worry about materials, right? And your data and your observations your data and your results could all be one little topic, right? Because it's going to be just the pretty data that you're showing me. Okay, so let me show you a couple of other functions about Excel, right? So here we have our grade. So these are all of the grades that I've gotten in this class. You know, I'm not the best student. So if I want to calculate my average, then what I'm going to do is I'm going to hit equal, and then I'm going to type in average. So as I type in equal, it pulls up functions, right? And as I start typing in average, it gives me the first thing it gives me is the average deviation, which is not what I want. I just want a standard average. So I'm just going to click the one that says average. So then I'm going to select what I want to take the average of. I'm going to close that parentheses. And so that gives me my average grade. Okay. So let's say I wanted to find the standard deviation. So then, let's see. So then what I would do, hit equal again. And if I hit ST, this here, and it actually tells you what it is. It says, calculate the standard deviation based on the population of a given, population given as arguments. Or I can calculate the standard deviation based upon a sample. So in that case, a population would be like everything. A sample would be just a small subset. So then, again, I would just select what I want to calculate the standard deviation of, close that parenthesis, and then that gives me my standard deviation. Let's say I don't want 5 significant figures, I just want 2 significant figures. So then I could just adjust what's being shown to me by hitting the decimal point going one way or the decimal point going the other way. Questions?
No.
Okay. So if you guys had a collection of temperatures and you want to calculate, you want to graph if the temperature is falling or rising, and then if you wanted to calculate the, let's say you wanted to calculate whether the curve is a linear curve or not, how would I do that? Let's say we have, actually, I'll give you one more thing. Let's say I had, let's go 3C. Okay, so this is my temperature in degrees Celsius. Let's say I wanted to change it to Fahrenheit and to Kelvin. Let's do Kelvin because Kelvin is easier. And then we'll do Fahrenheit. Okay, so what is my equation for changing into Fahrenheit? To Kelvin.
Minus it by 273.15.
I minus it by 273?
Well, that's if you're going to Kelvin to the other one. So
I'm going from Celsius to Fahrenheit. To Kelvin, sorry. Celsius to Kelvin.
Got it.
I add it. Okay, so then to do this, I would say I wanted to do C, and you said plus 273? 0.15. Okay, so now I just hit that one. So do I want to type all of them? No. So all I do is I will drag that all the way down. And so it will actually do each of the individual ones for me. So I've changed them all to Kelvin. Piece of cake? Okay, what is the equation from changing from Celsius to Fahrenheit?
It's 9/5 degrees Celsius plus 32.
Okay, so you said 9 divided by 5, and that's usually multiplied by our Celsius, and you said plus 32. So let me put that in parentheses. Plus 32. Now I just changed everything into Fahrenheit. So if I wanted to graph temperature over time, let's not do all the scales together. It's just gonna be a hot mess. And then I want to do a curve fit. Man, my data is beautiful. I wish that would happen in real life.
Hmm.
Okay, piece of cake so far. And let's say we want to name our axes. So well, it's not showing it, is it? So what you guys may get is a set of data, and then you're going to have to manipulate that data. Give me the standard deviation. Give me the average. Make me a graph. Something along those lines. Piece of cake?
Yeah.
Yeah.
Okay. Or convert. Questions? No questions?
No. No questions.
So does anybody want this table? I'll give it to you for $5.
That
I'm joking. I'll give it to you for free. Let me save it real quick.
we do this to all the parts on this lab?
Yep, you can use this for all the parts on the lab.
All right, so we just find everything like what you just showed us with each data.
Yep.
All right.
Are there any questions?
Not really.
Okay. Well, that's all I got for today. We'll save molarity for next week after your exam, after your brain is fried.
There.
Okay.
So how many milliliters of 0.1 molarity sodium chloride would be required to make 0.035 molarity solution of sodium chloride when diluted to 150 milliliters with water?
Okay.
And I didn't know where to start because I know that there's the formula M1V1 equals M2V2, but I wasn't too sure if that one was the one needed for this question.
Yep, it is. Often we will say, instead of saying M1V1, we'll say C1 V1.
Oh, concentration.
C2 V2.
Okay. So the the C1 would be the 0.1, right?
Yep.
So then it'll be 0.1 moles over liter. And then the V1 would be the 150, right?
So your V1, so C1 is going to equal your 0.100 molar.
Mm-hmm.
And then you set your V1, your V2, because you want to know V1, right?
Yeah.
So V2 is going to be 150.
And then concentration for that one would be the 0.035.
That's right. So that'll be your C.
Your C2.
And then you just solve for, oops, I ran out of room.
So then it would be
So you're solving for V1, right?
yes. So it would equal So will the answer be 52.5?
I didn't plug it in. I was waiting for you to give me the answer.
52.5 milliliters.
Sounds good. Plug it in. Let's see if he's right.
Okay. Oh yeah, nice. So that's the same case for 74.
Mm-hmm.